Okay, everybody, in this lesson, we're looking at circular functions in real-world problems. And what do we mean by circular functions? We mean functions that are applicable with the unit circle. So we're going to be looking at sine and cosine functions for this lesson. So example 1, we've got a number of visitors to a ski resort in Switzerland modeled by this function, where x is the number of months after January 1st. So there's 12 months in a year, so we just want to make a note that we're going to be talking about 12 months total. That helps us to set our window. And it says sketch the graph using your calculator. We come into our calculator. The first thing we want to do is we want to make sure that our mode is set to radians. We're going to go to y equals. We're going to enter in our function. And then we're going to go to window, and we're going to set an appropriate window for this graph. The number of months is 12, so we know we're going from 0 to 12. And I think an appropriate scale would be 1 there. And if we look at our function again, the center of our graph is occurring at 10,000. The distance from the center is our amplitude, that's 3,000. So we'll have a maximum of 13,000, 10,000 plus 3,000. And we'll have a minimum of 7,000, that's 10,000 minus 3,000. So our minimum's 7,000, our maximum's 13,000, and I think a good scale would be 1,000. So let's see if that works. We're going to hit graph. So we have a good sketch of our graph. We can have an idea of what it looks like. So let's go ahead and sketch that out in our notes. So we know that we have a minimum value of 7,000. We have a center at 10,000. And we have a maximum at 13,000. And I'd just like to draw a dashed line to just give me a guideline for my maximum, center, and minimum. And the y-axis is giving us the number of visitors, so we want to label the axis. The x-axis is the number of months. It's the number of months after January 1. And that's going from 0 to 12. All right, so let's go back and look at the graph. All right, so we have a general idea of the shape. We're just going to sketch that in. That's good enough. What is the maximum number of visitors, and when does this occur? So we want to just look at the maximum for the curve that we drew. We're going to find this value here. This is our maximum. This is our minimum. So we're going to go back to our calculator. We're going to go to second trace, and we're going to find the maximum, number 4, and we're going to move our little spider a little to the left of that maximum value. Hit enter, move a little to the right, hit enter, and hit enter. And we get a maximum value of 1,13,000. So that means that we had 13,000 visitors 1 month after January 1st, so that would be February 1st. Letter C says, what is the minimum number of visitors and when does this occur? So now we have to go back to our calculator and we have to find the minimum on the graph. So we're going to go to second trace. We're going to choose number 3, and then we're going to move our little spider a little to the left of the minimum value. We're going to hit enter, move a little to the right, hit enter, and hit enter again. And this time we get a value of 7.28, 7,000. So remember that the x value is telling me how many months after January 1st. Well, I know that it's 7 months after January 1st. So 7 months after January 1st would put me in August. 7 months after the first month would put me in August. And then I have this value of 0.28. So 0.28, I just want to calculate exactly what date in August it would be. There's 31 days in August, so 0.28 times 31 gives me 8.68. So I have 7,000 visitors on August 9th. In part D, how many visitors rounded to the nearest whole number are there at the resort on May 1st? Okay, well, May 1st means that we're looking at an X value of 4 because we have February, March, April, May. That's 4 months after January 1st. So we want to put an X value of 4 into our equation, or we could look at the table of values for 4 and we could see how many visitors we have at that time. So I'm going to do the easy way. We're going to go to our table and we're going to look at the value of 4 and we get 10,212 visitors. All right, let's move on to example 2. Ben is a fisherman with a boat in Stone Harbor. This is part of a graph of the depth of the water at the mouth of the harbor. Find the amplitude and the period of the function. So let's do amplitude first. Amplitude is the distance from the center. Well, the minimum of the graph happens at 2. The maximum happens at 8. 2 plus 8 is 10. 10 divided by 2 is 5. Our center is happening at a value of 5. From 5 to the maximum is 3, or from 5 to the minimum is 3. So we know that our amplitude is equal to 3. And I'm just going to make a little dashed line right at 5 so that I remember that my center is happening right at 5. Right, now we need to know the period. So we need to look at the graph and sort of figure out where's a good starting point. I mean, here it starts right at 4, right, this part. And where does it start to repeat? It goes from 4 to 16. So it starts to repeat at 16. So the period is 16 minus 4, which is 12. Now, you didn't have to start where I started. You could have looked at the graph and said, oh, well, I start at 10 and I don't start to repeat to 22. Well, 22 minus 10 also gives me 12. All right. Find B, the number of cycles. Well, we know that our period is equal to 12. And in this case, we're looking at a cosine graph. The period of cosine is 2 pi over b. We know the period's equal to 12. So we're going to cross multiply. So we're going to get 2 pi equals 12b. Divide both sides by 12. And we're going to get 2 pi over 12 equals b. And if we simplify that further, we're going to get pi over 6 equals b. It says find the vertical and horizontal shift. All right. Well, our cosine graph is starting. First place we can really see it starting is right here at 4. So we know that there's a horizontal shift right 4. And the center of our graph, which is going to be our vertical translation, is at 5. So we have a vertical shift up 5. So now we have everything we need to write down the equation for the function for the depth of water in terms of M and H. M is the depth and H is the hours after midnight. All right, so let's write that out. The function, when we put in hours, hours is going to be our input value. We know that our amplitude of our function is 3. It's a cosine curve. The value of b is pi over 6. Right. We're moving our graph right 4 So that means we're going to have -4 in the parentheses with h, and the whole graph is being moved up 5. Letter E says, calculate the depth of water at 9:30 a.m. Well, 9:30 a.m., that's 9.5 hours after midnight. So that means we're going to be putting an input value of 9.5 into our equation. We're going to put that into our calculator. And we get a value of 2.1, and depth is in meters, so we want to make sure we include units when we write out this output value. All right, last part is letter F. Ben's boat can only get in and out of the harbor when there is at least 4 meters of water at the mouth of the harbor. Ben sleeps until 10. Find the next time that he can go fishing. All right, so we know that the output value has to be 4. And so we just want to put those values. We're going to put the left side in y1. We're going to put the right side in y2. And we're going to look for the intersection point. So let's go ahead and do that. Right, so we've entered our equation into the calculator, and now we want to set our window. Setting the window is going to help us make sure that we find the right intersection point. All right, so now we want to set our window, and we know that we're looking at Ben sleeping until 10 a.m. So we know that our minimum value has to be 10. We know that the maximum value is 24. There's only 24 hours in a day. And I think a scale of 1 will work for that. And then our minimum value, we know on the y-axis is 2, the maximum is 8, and I think a y-scale value of 1 works for that. So let's go to the graph. And now we just want to find the first intersection point that occurs in that window, and we see it happening right here. So we're going to go to second trace, number 5, and we're just going to move closest to that intersection. Once we're close, first curve, enter, second curve, enter, guess, enter. And we get a value of 12.35, 4. So we know we're happening after noon, 12 o'clock noon, but 0.35 is how many minutes in the hour. So we need to figure that part out. So 0.35 times 60 minutes give us 21 minutes. So we know that the next time that Ben can go fishing is 12:21 p.m. Right, in example 3, we're looking at a Ferris wheel problem. And when we do that, we are always going to be looking at a cosine curve, because if we reflect a cosine curve over the x-axis, it'll look something like this. And so that means that we're going to start at our lowest height when we get on the Ferris wheel. We'll get to the top height at the top of the Ferris wheel, and then we're going to come back down. So Ferris wheel problems are always modeled using the cosine curve with the value of a, that's going to be less than 0. We're going to have a negative a value. So it says the Ferris wheel moves with a constant speed and completes 1 rotation every 40 seconds. Well, 1 rotation gives us the period. So let's just make a note here that 40 is going to be our period. The wheel has a radius of 12, and at its lowest point is 2 meters above the ground. The height of the chair on the Ferris wheel above the ground can be modeled by the given function, where t is time in seconds. So part A, mark the sketch of the Ferris wheel with the given information. So we know that the radius of the wheel is 12. So from here to here is 12, from here to here is 12. And we also know that at its lowest point, we're 2 meters above the ground. So we have a value right here of 2. Right? The center then of our Ferris wheel is 2 plus 12, that's 14. So remember, the center is the vertical translation. So that'll help us out when we get to that part. All right, so we have it marked up. It says find the values of A, B, and C. So in this function, the value of A right here represents the amplitude, which is the distance from the center. And the distance from the center is equal to 12. But remember, I said that we are going to be using a cosine curve with a negative A value because we're going to be starting at our lowest point and working up to our highest point. So in this case, the value of A is negative 12. Now the value of B is the number of cycles in a period. Well, we know that the period is equal to 40. And in a cosine curve, to find B, the value of the period is equal to 2 pi over B. So we're going to solve for B. We'll cross multiply. So we're going to get B equals 2 pi over 40. And if we simplify that, we'll get pi over 20. Right, so far so good. We've got our A value, we've got our B value, and then they want us to find right here the vertical translation, and we know that the vertical translation is the center of the graph, so we know that C is equal to 12 plus 2, or C is equal to 14. Then it says write the function once you know that. The chair reaches a height of 20 meters above the ground after t seconds. Find the angle that the chair has rotated through to reach this position. All right, so we know that the equation is going to be equal to 20. And at this point, all we have to do is solve for t. We'll subtract 14 from both sides. Divide both sides by negative 12. So 6 divided by negative 12 is negative 1/2. And then to solve for t, we need to know where on the unit circle is the cosine negative 1/2. The cosine is negative 1/2 at 2 pi over 3, and it's negative 1/2 at 4 pi over 3. Now, if we think about this problem, it's saying that the chair first reaches a height of 20 meters above the ground after t seconds. We're trying to find the angle. Now, if you look at our picture that we drew, the highest the chair would get would be 24. So we're trying to say here, when does the chair first reach 20? Well, it's past 180 degrees at 4 pi over 3. So we're more than halfway around, and we know this happens before we're halfway around. So we know that the angle that we have to be choosing in this case is definitely going to be 2 pi over 3 and not 4 pi over 3. So we need to know the value of t for that angle. So far, all we know is that 2 pi over 3 equals pi over 20t. So we need to know the time. We found the angle, now we need to know the time. So in order to solve for t, we're going to multiply both sides by 20 over pi. And when we do that, we're going to get t is equal to 40/3, which is approximately 13.3 seconds. All right, moving on to example 4. The height in meters of the tide on New Year's Day in Perth, Australia can be modeled by the given function, where t is the number of hours after midnight. Sketch the graph using your calculator. All right, so we're going to go ahead to our calculator. We're going to make sure our calculator is in radians. You go to mode. If you're not sure, you make sure radians is highlighted. We're going to go to y equals, and we're going to enter in our function. Once we have our function entered, we go back, and we're going to decide what the scale should be for our window. We know that the center is at 7. The center is at 7. The amplitude is the distance of the center, Our amplitude is at 5. So 7 plus 5 gives me 12. 7 minus 5 gives me 2. And T is the number of hours after midnight, so we know we're going to 24. So we'll go to our window. We'll enter in 0 for our x-min. The x-max is 24. Scale of 1 is fine. The minimum value is 2, maximum value is 12, and the y scale of 1 should work. We'll go to graph. And now we'll get an idea of what our graph should look like between 0 and 24. And let's go ahead and sketch that in our notes. Okay, that looks about right. So we've done the sketch, find the maximum value. We already have it marked. We know that that's 12 meters. Find the minimum value. We have that marked. That's 2 meters. What time is high tide? So we need to look at both the maximum values on our graph to find the times. We're going to do second calc, number 4. We're going to move a little to the left of our first maximum point. Hit enter, move a little to the right, hit enter and hit enter. We get a value of 812, and then we'll check the other maximum, second trace, number 4. Move a little to the left. Again, we just want to be a little to the left of the maximum, hit enter. Move a little to the right, hit enter, and then guess, hit enter. And the other value we get is 2012. So at what time it's saying, so this is happening at 8 o'clock a.m. And this one is happening 8 hours after noon. So this is happening at 8 o'clock p.m. 20 is 8 hours after noon. Okay, what is the low tide? So this time we have to go and calculate the minimums on our graph. Second trace, number 3. Move to the first minimum, a little to the left of the first minimum, hit enter. Move a little to the right. Hit enter, guess, hit enter. We get a value of 2, 2. All right, let's try checking the other minimum, second trace, number 3. A little to the left, hit enter, to the right, hit enter, guess, hit enter. We get a value of 14.2. So the first value means 2 o'clock a.m. And then the 14 occurs 2 hours after noon. So that's 2 o'clock p.m. What is the depth of the water at 9 a.m.? So in other words, take your function and put 9 in as an input value. Or we could check the table of values, which I think is going to be the easiest thing. So we're going to go to the calculator. We'll go to the table, second graph, and we'll look at the value of 9, and we get 11.33. Want to make sure you include units, which is meters. Find all the times during a 24-hour period when the depth of the water is 3 meters. So we want to go back to the calculator, go to y equals. We have our function, but we just want to see, we're going to put 3 in, and we want to look at the graph now, and we want to see all the places in which this graph is intersected. And you can see that there's 4 intersection points. I'm not going to do all 4 with you. I'll show you the first one. We're going to do second trace, and we're going to do number 5. And we're just going to make sure for whatever intersection point we're trying to find, we're going to move the little spider nearest that intersection point. Just want to be nearest. Once we're near our intersection, we're going to hit enter 3 times. And the first intersection happens at 0.773. So we just need to write the x values, but you're going to do that 4 times. You're going to do it for this intersection, this intersection, this intersection, and this intersection. And the question is asking find the times. So 0.77, we want to know at what minute that is. So we need to do 0.77 times 60 because there's 60 minutes in an hour. So that means the first time happens at 46 minutes. We know the next one is happening at 3, and then 20.23 times 60 to find the minute after 3 o'clock. That gives us 14 minutes. So we're at 3:14. And then the next one, we have to calculate 0.77 times 60. And that gives us 46 minutes. So the next time is 12:46 p.m. And then the last one is 0.23 times 60. Again, that gives us 14 minutes. So those are all the times in the 24-hour period where the depth of water was 3 meters. All right, this is the last problem, example 5. In a physics experiment, a weight is attached to the end of a long spring and bounces up and down. As it bounces, its distance from the floor can be modeled with a cosine function. The weight is released from a high point of 60 above the floor at 0.3 seconds and first reaches its low point at 40 centimeters above the floor at 1.8 seconds. So it says to sketch the graph. So we know that the low point is at 40 and the high point's at 60. So that means the middle of the graph is at 50. We know that it's at 60 at 0.3 seconds. And we know that, so we have a value here, 0.3 at 60. And we know that it reaches its low point of 40 at 1.8 seconds. So this is the sketch of the graph, what we know so far. So it says write an equation to model the distance of the weight from the floor in seconds. And just as a reminder, this is our height, and our height's in centimeters. And this is our time, and it's in seconds. So we know that our amplitude is going to be the distance from the center. So the amplitude is equal to 10. The distance from the center of the graph is 10. So we know our amplitude is 10. The next thing we need to do is identify the period. Well, this graph, this is like half a graph, and this graph is going to start to repeat once we double this. So, well, how far are we going? Well, what's 1.8 minus 0.3? That gives us a value of 1.5. And if we just double that, that'll tell us, how long one period is. So 2 times 1.5 is 3. So we know our period is 3, and that's equal to 2 pi over b. Cross multiply. So the number of cycles is 2 pi over 3. We need to know our horizontal shift. Our horizontal shift is going to be, the graph starts here, so we know that our horizontal shift is at 0.3. So we're going right 0.3. And we also need to know the vertical translation, what's the center, and that's going to be up 50. All right, so we have everything we need now to write our function. The height over time is equal to our amplitude We were told it's a cosine curve. B is 2 pi over 3. This function we said is moving right 3, so it's going to be minus 0.3, and our center is at 50. Find the distance of the weight from the floor at 17.2 seconds. So in other words, we have to input 7.2 into our equation to solve. I'm going to use my calculator to do that. We're going to go to y equals, and we're going to enter the equation. And be very careful when you enter this equation that you use parentheses. I want to look at my table, but I want to make sure my table is set to the value that I need. So I'm going to go to second window, which gives me table set. And I just want to start my table right at the value I'm going to be looking for, 17.2. We'll go to table, second graph. And at 17.2, I'm 43.3 meters. And then last part, find the time when the weight was first 59 centimeters above the floor. So the entire equation is going to be set to 59. The easiest way to solve this would be to put the first part in y1 and the second part in y2 and look for the intersection. So go back to y equals. We already have our equation entered. We're going to enter in 59. And we just want to set our window to be something that works for this problem. I'm going to make my minimum 0, my maximum 2. My x scale should be 0.1. My y min is 40, y max is 60, and my y scale is 1. That should work. We're going to look at the graph. And we're going to look at that very first intersection point there. Second trace, number 5. And we just want to move near that first intersection point because the question is asking you, find the time when the weight was first 59 centimeters. So we want to find that first value. Okay, we're going to hit enter 3 times. And we get a value of 0.08. All right, everyone. This was a long lesson. Thanks for watching to the end. Have a great day.